adding a 100 amp subpanel fed from a 100 amp breaker in the main 200 amp service, the grounded and grounding conductors must be kept separate. The two bus bars in the subpanel should not be bonded together. This is because in a subpanel fed from a feeder, the feeder must be protected by a single overcurrent protective device located in the main service panel. The grounded conductor must be at least the same gauge as the ungrounded conductors, and it must be insulated. The grounding conductor, on the other hand, is typically bare or green insulated and is used to connect the subpanel to the main service panel's grounding system to establish a path for fault currents. To feed the subpanel without bonding the bus bars, you need to use a multi-conductor cable that includes separate grounded and grounding conductors. Service entrance cable, often abbreviated as SC cable, is available with a separate bare ground wire. This type of cable is commonly used for subpanel installations. The service entrance cable must be sized appropriately for the 100 amp subpanel. The grounded conductor must be the same gauge as the ungrounded conductors. The grounding conductor must be bare or green insulated and at least 14 American wire gauge. The subpanel should be clearly labeled as a separately derived system. An equipment ground bar must be installed in the subpanel, and the grounding conductor from the feeder must be connected to it. When dealing with electrical installations, it is always recommended to consult with a qualified electrician for proper installation and compliance with local electrical codes. This ensures safety and adherence to regulatory requirements. Furthermore, it's essential to understand the specific role and requirements of grounding and grounded conductors in electrical systems. Firstly, grounding conductors provide a low impedance path for fault current to return to the source, which helps to quickly trip a circuit breaker or fuse, thereby minimizing the risk of electrical shock or fire. Secondly, grounded conductors, also known as neutral conductors, provide a return path for normal load current. In a properly wired system, current flows from the source through the load and back to the source via the grounded conductor. The National Electrical Code, often referred to as NEC, provides comprehensive guidelines for electrical installations, including requirements for grounding and bonding. The NEC specifies that the grounding and grounded conductors must be kept separate in subpanels to prevent circulating currents and ensure proper operation of overcurrent protection devices. Bonding refers to the practice of connecting metallic parts of an electrical system together to create a low impedance path for fault current. Bonding is essential for safety, as it helps to ensure that all metallic parts are at the same potential, which minimizes the risk of electrical shock. In a subpanel, the equipment grounding bus should be bonded to the metal enclosure of the subpanel. However, the grounded conductor bus should not be bonded to the enclosure or the equipment grounding bus. This separation of grounding and grounded conductors is a fundamental principle of electrical safety. When selecting service entrance cable for subpanel installation, it's important to choose a cable that is appropriately sized for the load and that includes separate grounding and grounded conductors. The cable should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, often referred to as UL, to ensure that it meets safety standards. In addition to the requirements for grounding and bonding, there are also specific requirements for overcurrent protection in subpanels. The NEC requires that each subpanel be protected by an overcurrent protective device, such as a circuit breaker or fuse, that is sized to protect the conductors feeding the subpanel. The overcurrent protective device should be located at the point where the feeder conductors originate. Furthermore, it's important to properly label all circuits and equipment in an electrical system. This helps to ensure that workers can safely identify and work on the correct circuits. The NEC requires that all circuits be clearly labeled with their purpose and voltage. Subpanels should also be labeled to indicate that they are separately derived systems and that the grounding and grounded conductors are kept separate. When working on electrical systems, it's essential to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using properly insulated tools. It's also important to de-energize circuits before working on them and to verify that they are de-energized using a voltage tester. Electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. The importance of correctly installing a subpanel cannot be overstated. Firstly, a correctly installed subpanel will ensure that the electrical system is safe and reliable. Secondly, a correctly installed subpanel will meet the requirements of the NEC and local electrical codes. Thirdly, a correctly installed subpanel will protect the occupants of the building from electrical shock and fire hazards. The size of the subpanel is determined by the anticipated load that the subpanel will serve. It is important to calculate the load accurately to ensure that the subpanel is not overloaded. Overloading a subpanel can cause the circuit breakers to trip frequently, and it can also damage the electrical equipment connected to the subpanel. The location of the subpanel should be carefully considered. The subpanel should be located in a dry, accessible location that is protected from physical damage. The subpanel should also be located close to the loads that it will serve to minimize voltage drop. The type of wiring used to feed the subpanel is also important. The wiring must be sized appropriately for the load and must be installed in accordance with the NEC and local electrical codes. The wiring should also be protected from physical damage. The grounding and bonding of the subpanel is critical for safety. The subpanel must be properly grounded to provide a path for fault current to return to the source. The subpanel must also be bonded to other metallic parts of the electrical system to create a low impedance path for fault current. The overcurrent protection of the subpanel is also important for safety. The subpanel must be protected by an overcurrent protective device such as a circuit breaker or fuse that is sized to protect the conductors feeding the subpanel. The overcurrent protective device should be located at the point where the feeder conductors originate. The labeling of the subpanel is important for identification and safety. The subpanel should be clearly labeled with its purpose and voltage. The circuits in the subpanel should also be labeled to indicate the loads that they serve. When installing a subpanel, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and using properly insulated tools. It is also important to de-energize circuits before working on them and to verify that they are de-energized using a voltage tester. Understanding American wire gauge, or AUG, is critical for selecting the right wire size for the amperage. For a 100 amp subpanel, appropriate wire gauges are needed for the feeder conductors. In copper wiring, typically, number 3 AWG copper conductors are used for 100 amp circuits. However, it's important to consult the NEC table 310.15b16 to determine the appropriate wire size based on the conductor's insulation type and the ambient temperature. Aluminum wiring has a lower conductivity than copper, so a larger gauge is required for the same amperage. Typically, number 1 AWG aluminum conductors are used for 100 amp circuits. Again, refer to the NEC table 310.15b16 for specific requirements. The type of insulation affects the ampacity of the wire. Common insulation types include THHN, THW, and XHHW. Each insulation type has a different temperature rating, which affects the amount of current the wire can safely carry. Check the wire's insulation type and its corresponding ampacity rating in NEC table 310.15b16. The length of the wire run affects the voltage drop. Longer wire runs result in greater voltage drop. To minimize voltage drop, use a larger wire gauge. Calculate the voltage drop using a voltage drop calculator or consult the NEC Chapter 9, example number 1, for guidance. The number of conductors in a raceway or cable affects the ampacity of the wires. When multiple conductors are bundled together, their ampacity must be directed to prevent overheating. Consult NEC table 310.15 current for directing factors. The terminals and lugs in the subpanel must be rated for the wire size and type being used. Ensure that the terminals are properly tightened to provide a secure connection. Torque the terminals to the manufacturer's specifications using a torque screwdriver or wrench. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the wires from overcurrent. The overcurrent protection device should be sized no larger than the ampacity of the wire. The NEC provides specific rules for sizing overcurrent protection devices in Article 240. Grounding is essential for safety. The grounding system provides a path for fault current to return to the source, which helps to quickly trip a circuit breaker or fuse. The grounding system must be properly installed and maintained to ensure its effectiveness. Bonding is the process of connecting metallic parts of an electrical system together to create a low impedance path for fault current. Bonding helps to ensure that all metallic parts are at the same potential, which minimizes the risk of electrical shock. The NEC provides specific rules for bonding in Article 250. The service entrance cable must be suitable for the environment in which it is installed. For example, if the cable is installed outdoors, it must be rated for wet locations. The cable must also be protected from physical damage. The NEC provides specific rules for protecting cables in Article 300. When installing a subpanel, it's important to follow all applicable codes and standards. The NEC is the primary electrical code in the United States. Local codes may also apply. It's important to consult with a qualified electrician to ensure that the subpanel is installed correctly and safely. Remember that improperly installed electrical work can be dangerous and can lead to fire or electric shock. Always hire a qualified electrician to perform electrical work. It is essential to understand the principles behind keeping grounded and grounding conductors separate in a subpanel. Firstly, separating the grounded and grounding conductors prevents unwanted current flow through the grounding path during normal operation. If the grounded and grounding conductors are bonded together at the subpanel, a portion of the neutral current will flow through the grounding conductors, which can cause nuisance tripping of ground fault circuit interrupters, often abbreviated as GFCIs, and can also create electromagnetic interference. Secondly, separating the grounded and grounding conductors ensures that the grounding system is only used for fault current. The grounding system is designed to provide a low impedance path for fault current to return to the source, which helps to quickly trip a circuit breaker or fuse. If the grounded and grounding conductors are bonded together at the subpanel, the grounding system may not be able to effectively handle fault current. Thirdly, separating the grounded and grounding conductors is required by the NEC. The NEC specifically prohibits bonding the grounded and grounding conductors together at the subpanel in most situations. This requirement is intended to ensure the safety and proper operation of the electrical system. When installing a subpanel, it's important to follow the NEC guidelines for grounding and bonding. The NEC provides specific requirements for grounding electrode systems, grounding conductor sizing, and bonding of metallic parts. It's also important to use the correct type of service entrance cable. Service entrance cable with a separate grounding conductor is specifically designed for subpanel installations. This type of cable includes an insulated grounded conductor, a bare or green insulated grounding conductor, and one or more ungrounded conductors. When connecting the service entrance cable to the subpanel, it's important to properly terminate the grounding and grounded conductors. The grounding conductor should be connected to the equipment grounding bus in the subpanel. The grounded conductor should be connected to the neutral bus in the subpanel. It's important to ensure that the connections are tight and secure. In addition to following the NEC guidelines, it's also important to follow the manufacturer's instructions for installing the subpanel and service entrance cable. The manufacturer's instructions may provide additional details and recommendations that are not covered in the NEC. It's always a good idea to consult with a qualified electrician when installing a subpanel. A qualified electrician can help to ensure that the subpanel is installed correctly and safely. They can also answer any questions you may have about grounding, bonding, and other electrical issues.